Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 3-3 Part 1 homework solutions on solving by square roots and by completing the square. To solve this first equation by using square roots, we're going to have to factor the left side of the equation. So I can use my a minus b squared shortcut to do that, since this is a perfect square trinomial. So basically, square root the first and the last thing and stick those things in a parentheses with the sign of the middle term. So we've got the square root of x squared, which is x, and square root of 16 is 4. We have a minus middle term, so throw that in there as a minus 4 and square that parentheses. Now, if you want to check to make sure you factored this correctly, you can multiply these two terms in here together and double it. If we do 2 times x times negative 4, it does become negative 8x, so that tells us we did this correctly. Now that we've got 1/2 of the equation as a squared binomial, we can take the square root of both sides. So that'll give us x minus 4 on the left side, and on the right side, remember when you square root an equation, you need a plus or minus, so this is plus or minus 5. To get x by itself, we just add 4 over to the other side. And because we can combine 4 and 5, we're going to do that. So 4 minus 5 is negative 1, and then 4 plus 5 gives us our other answer of 9. For this problem, to solve by square rooting, we're going to first turn the left side into a perfect square binomial. So we just have to square root the first and the last perfect squares there and put it in a squared parentheses with the sign of this middle term. Square root of x squared is going to be x. Square root of 81 is 9. Because the middle term is negative, we'll write minus 9 and square that parentheses. And then if I square root both sides of the equation, we've got x minus 9 and plus or minus the square root of 5. And we'll just add 9 to the other side to get x by itself. So 9 plus or minus radical 5. To solve this equation by completing the square, I have to first clear this 7 out, so I leave room for a constant that I'm going to add in later. So let me subtract that to the other side. And now for the actual completing the square part, we take half of our b value, which is this negative 10, so half of that, negative 5, square that and add that to both sides. That allows us to factor the left side as x minus 5 quantity squared. And on the right side, we just have negative 7 plus 25. I'll simplify that now. All right, now we can square root both sides. On the left side, I've got x minus 5. On the right side, I've got plus or minus the square root of, this becomes 18. And I'm going to simplify 18 over on the side here. I can split that up into radical 9 and radical 2. I just need a perfect square times something. Square root of 9 is 3, so this is 3 radical 2. And now coming back over here, to get x by itself, I need to add 5 over to the other side. So I end up with 5 plus or minus, this became 3 radical 2. To solve this one by completing the square, let me first move this 3 over to the other side so that I can add whatever constant I want in here without worrying about that 3. And now I'm just going to take half my b value, half of this 6 here, which is 3, square that and add that to both sides. Now that I've done that, I can factor my left side as x plus 3 quantity squared. And on the right side, I still have this negative 3 and a plus 9. With the squared binomial over here, I can square root both sides now. That leaves me with x plus 3 on the left, and on the right, we'll have plus or minus square root of, this is going to be 6. And then don't forget to actually move the 3 over here, so we'll have x equals negative 3 plus or minus radical 6. On this one, to solve it by completing the square, I need to take care of a few things first. For one thing, I need to move this constant over to the other side. I also need to get rid of this 3. I want 1x squared if I'm going to do the completing the square step. Let me take care of the 3 first. It doesn't really matter what order I do those in, though. So dividing everything by 3, we've got x squared plus 4x plus 5 equals 0. And now let me just subtract this 5 over there. All right, so x squared plus 4x. That's what I'm completing the square on now. So I'm going to take half of my b, so half of 4, which is 2, square that and add that to both sides. That lets me factor the left side as x plus 2 squared. And on the right side, I've got negative 5 plus 4. So now I can square root both sides. That'll leave me with x plus 2 on the left and plus or minus the square root of negative 1 on the right side. So to get x by itself, let me subtract 2 over there. And I know that square root of negative 1 can be expressed as I, so let me just write plus or minus I. To solve this one by completing the square, I need to move this constant over, and also I need to divide by this 7 to get just a 1 for the a value here. Let me do the 7 first. So dividing by that, we end up with 1t squared plus 4t plus 8 equals 0. And I also want to move this 8 over to the other side so I can throw whatever I want on the left side and not worry about constants that are already there gumming up the works. All right, to actually complete the square, I need to take half of my b value, which is 2, and square that and add it to both sides. So that lets me factor my left side as t plus 2 squared. On the right side, I've got negative 8 plus 4. Now I can square root the left side. That leaves me, both sides actually, that leaves me with t plus 2. And plus or minus the square root of, this will be negative 4. Now the square root of negative 4 can be written as 2i. So this will be negative 2 plus or minus 2i for my final answer.